So, good evening, ladies and gentlemen. In the last few years, we have seen the emergence of several technologies, whether it's 3D printing, blockchain technology, digital twins, the cloud computing model, the cloud technologies. We have seen several technologies. And many technologies have been successful. Cloud has been consistently successful in terms of adoption. But there have been certain technologies which is probably taking a bit of a time for them to be reaching the prime slot, the prime time. Digital twin probably is also another technology like blockchain, because even blockchain we have been talking for several years now, correct? But has blockchain reached the prime time? Probably not. Is it a technology that is a failure? Definitely not. But it's taking a longer time than what one had envisaged at that point in time in terms of that technology being democratized or commoditized. So similarly, even digital twin we have been talking of quite some time. And it's taking a slightly longer time for that to get productionized or commoditized. But I want to introduce you to this concept of, I talk of these technology couples. So you find that these standalone technologies, when you look at these as standalone technologies, it could be blockchain again or a digital twin. These standalone technologies, as I said, is taking time for them to really kind of mature. But with the advent of newer technologies, for example, if it is digital twin along with generative AI, will that not be a very, very powerful, potent kind of a combination? Will 3D printing along with generative AI, will that not become a very, very potent kind of a combination of technologies which will be highly successful in the future? We don't know at this point in time, and it's difficult to forecast. I'm just foreseeing a day when these technology couples combine together. When technology is combined, it need not be just two technologies. I talk of technology couple, it could be a technology triplet also, right? Technologies combined together will make it that combination of technologies highly, yes please? Highly kind of potent and very, very successful. So having said that, I just wanted to open up this discussion on digital twin with a video. This video is of General Electric. General Electric is one of the largest manufacturing companies. They were manufacturing locomotives, steam turbines, wind turbines, healthcare equipment and whatnot. They have very successfully kind of built digital twins and built very, very powerful kind of platforms. I just want to play this video. It's a long video, but I'll play it only for about 2 minutes, 40 seconds, I guess, right? Have a look at that. You will get an idea of how digital twins are really helping organizations to reimagine the way they conduct business today.
Operator, a change in my mission is causing damage to my HP turbine rotor.
Okay, Twin, help me understand the problem. What's your operating profile?
In past 6 months, my number of cold starts is 4, my number of warm starts is 8, my number of hot starts is 39, the number of start-stop cycles has increased by 27.5%.
Okay. Twin, tell me about your rotor damage.
My damage rate has increased by 4.0 times over last 6 months. If this continues, I would lose 69.9% of my useful life.
Twin, give me options for mitigating that rotor damage.
Based on weather forecasts, historical data, fuel cost, electricity pricing and my present condition, I have two options for you to optimize operations. Option 1 is to manually slow down my startup ramp rate so that you can reduce the wear on my rotor. Option 2 is to download the OpFlex app and apply stress controls to minimize wear and reduce fuel consumption too.
Twin, give me the factors you use to calculate option 2.
I used my past 15 years of historical data, fleet learning from 125 other D11 steam turbines like me, and 58,965 simulation runs to get this recommendation. I'm 95% confident of my assumptions.
Twin, I need a financial perspective. Tell me about the numbers.
The numbers look good. We can reduce stress by 25%, which brings the damage rate back to normal range. Startup fuel cost will go down by 40% and startup time will be cut by 50%. You will also avoid $12 million by preventing an unplanned outage.
Twin, okay, I select option 2. Let's do it.
It's a classic example of how a digital twin, we will come to a definition of what a digital twin is the next two slides. But digital twins are helping GE significantly in inventing new ways of supporting their products. There's another example of in the airline industry. I won't say the airline industry, but in the aviation industry, should I say. There is a flight which has taken off from London Heathrow, and it is heading towards Atlanta, Georgia, in the US. It's a 9.5 to 10 hours flight, depending on tailwind and headwind. 5 hours into the flight, and it's flying over the Atlantic, and all the passengers are asleep. 5 hours into the flight, there's a severe turbulence over the Atlantic Ocean. There is a severe damage to one of the aircraft engines. The passengers don't know about it, they're all sleeping. The captain observes this and then puts that engine on a slightly lower power mode. While all this is happening, data is being streamed from those engines live through satellites to Rolls-Royce Command Control Center. And by the way, these aircraft is fitted with Rolls-Royce engines. You have only Rolls-Royce, GE, Pratt & Whitney, and so on, the aircraft engine manufacturers worldwide. So these are fitted with Rolls-Royce engines, and the data is streamed to the Command Control Center of Rolls-Royce in Derby, in the UK. So you have engineers there who analyze the data which is coming from the engine with hundreds of those sensors. They analyze all this data and then decide whether, even before the flight has landed, it's another 4.5 hours for it to land in Atlanta. But they analyze, do a lot of simulations, and then arrive at a decision whether the aircraft has to be grounded when it lands in Atlanta, or with some minor repairs, it can still continue on the next sector and the next. These are all enabled by the digital twins of that aircraft engine. And by the way, Rolls-Royce, Pratt & Whitney's, even GE, they also offer engine. They don't sell engines sometimes. They sell engines also. They have another business model where they offer that on an OpEx model, like a cloud model, right? Based on number of hours of working, they charge the customer. So digital twin, I've been talking of only all these physical things. So digital twin is just not about things only. It is not about having a digital representation of something which is physical, right? It could be something like this also. So you could have a parent digital twin of an entire vehicle. I'll talk of a digital twin of a truck. And this is the digital twin of the instrument cluster which you have in your car. And today, Rucha was talking about automotive companies capturing a lot of data, right? And believe me, I can tell you because I come from the automotive industry, we 100% are able to replicate what the driver is seeing on the dashboard or on the instrument cluster with all the telltale signals. Whether it's engine oil is low, what is the coolant temperature, what is the engine RPM, what is the vehicle speed. Everything is tracked here back end. We are able to get the same information and then display that on a screen on a screen which is very, very similar to the instrument cluster. So digital twins of things, digital twins of even places also, right? It could be a digital twin of a city, which could be very, very useful when you're really designing smart cities. I'm saying, is the street view in Google Maps, is it not a digital twin? Right? It is a digital twin. And if you go to, Google Maps especially has covered that so well as far as the US geography is concerned. When you go for a street view, every single street, you have a street view of that. But that's a static data. That's also a digital twin. A digital twin of, we said, things, of process. So a manufacturing organization is trying to build a new assembly line. You can simulate the entire assembly line using tools which are available today, digital tools which are available today for you to simulate your entire assembly line, so that when you actually build your infrastructure, the amount of deviation and surprises that you will get when you actually build the physical infrastructure can be minimized. That's another digital twin. Digital twin of people, and I'll talk a little more about it in the subsequent slides. So what is the definition of a digital twin? The digital twin is a virtual representation, a digital representation of something which is physical. It need not be just physical, need not be a thing. It can be a process. It can relate to even people also. So if you look at the characteristics of a twin, it represents a physical asset. A twin is unique to a specific asset. More importantly, there are two types of data which makes up the digital twin. One is the static data. So when you manufacture a product, you have captured a lot of data in terms of a specification, your manufacturing data and so on. That is a static data. But you also have a dynamic data in terms of as the product is being used. For example, every truck which is running here in India, an Ashok Leyland truck running in India, is highly connected. We capture more than 4 terabytes of data, 2 or 4 terabytes, must have gone even more now, I guess, every day, getting into the AWS cloud and doing a lot of analysis and so on. So that is the dynamic data. So you're capturing the data throughout the life cycle of the product. So where do organizations stand in terms of adoption of twins? They're just about 11% of the enterprises are fairly matured in understanding what a digital twin is, and they have adopted digital twins. But a large majority of them, 88% who are into now attempting as part of Industry 4.0, IoT and so on, they understand what a digital twin is, but they're still to get their act together in terms of putting a very, very formal digital twin. This is none other than James Hackett. He was the CEO of Ford from 2017 to 2020. It's a very powerful statement. It's a very profound statement. He says we now have the vehicle in a bigger system. The opportunity for profit is now outside just the vehicle that we sold. It's probably equal in all the projections that we have done. So, which means to say that moving forward, today your majority of the bulk of the revenues you're getting is through sale of product. Going forward, you're going to have 50% almost by 2025, they say, that 50% of a company's revenues, especially for manufacturing industry, will be coming from solutions and services where digital twins are going to play a very, very major role in enabling this paradigm shift. So this is all about sensorization. So if you're talking of a physical product, you need sensors to capture data. And I just wanted to share with you a kind of a masterclass. This is my experience. You need to have a sensorization strategy in your organization in terms of what do you want to sensorize, where do you want to have sensors. I still remember my organization, we wanted a load sensor to track the amount of load that a vehicle carries. And they came out and designed one which costed about 25,000 rupees. Hey, come on, you can't have a sensor which is 25,000 where there's a rat race in terms of discounts which are happening on the field. The sales guys immediately rejected that. So your sensors have to be driven by the value that the data that you're going to capture from that particular component or assembly that's going to deliver to any of those 5 C's. They have to be benefited. You have to ensure that the value of data that you capture from the sensors have to benefit one or more of these 5 C's. Either your customer, your channel partners, the company, you benefit. Customer does not benefit, but the organization benefits significantly from capturing that data because it's giving me a lot of deep insights into the performance of my vehicle. Your collaborators in an automotive company, you have transporters, insurance companies, finances, and so on, and the community as a whole. If I were to share that data from all these vehicles I capture, humongous big data that is, right? If I were to share it with the National Highways Authority, they can lay better roads, I guess. And then I can share it with universities and institutions because they are now building a lot of AI models using machine learning and so on. I can share that data. That is a CSR, right? That is a corporate social responsibility. You're helping the community with the data that you capture. So that is what is community. And what we do, of course, this is a very live example of saying this is a mobile app for the drivers, right? Capturing every single item from the vehicle, data parameters from the sensors, we were able to put together a wonderful kind of an app or solution for the drivers, which tells the driver, if he is going from, say, Chennai to Bangalore, it gives him at the end of the trip, what is the score? How many times have you pressed the accelerator fast? How many times have you pressed the brake and then braked very, very harshly? How many times have you not driven in the right gear? And India, you believe me, and you will agree that India is a very, very mileage sensitive economy, right? So all this data is all available on the mobile. And we went one step ahead to say, can you predict even accidents with the kind of data that you capture, right? Do apply your algorithms there and then say, if you drive like this, I will send him an alert and then say, hey guy, if you're driving in the same way you're driving now, you're definitely going to meet with an accident. You can imagine these kind of applications which will be so very helpful in a country where your accident rates are so very high, the road fatalities are very, very high. All this because of these components of digital twins, solutions meant for the driver. So global examples, Rolls-Royce, as I said, we spoke about this. Every fan on that engine, right, captures humongous amount of data, terabytes and petabytes of data they analyze. From the engines, Rolls-Royce engines have hundreds of sensors. And I gave you that example, right, of a flight going over the Atlantic Ocean and so on, right? And then they use all this data they build digital twins of each of those components, ultimately the digital twin of that engine itself and that entire aircraft, and then provide a lot of insights, and they monetize this also. Similarly, GE, we spoke about this for steam turbines. We saw that video. This is for wind turbines. So how to build? I just wanted to leave you with a thought in terms of saying, this is not rocket science, right? I wanted to demystify this digital twin to say, when I say a digital twin of a truck, how do you build this, right? Let's get down to the brass tacks now, right? If you look at the entire cradle to coffin of a vehicle, from the time it is, the engine is kind of identified, it is put on the test bed for testing, you capture a lot of data. So one set of data which is going into the digital twin. Then the vehicle is assembled, you again capture data related to your assembly process, your quality inspection and so on. And then the vehicle is passed out, and then tested out. When you're testing the vehicle, you're again capturing a lot of data. These are all static data because you're capturing this once. Now the vehicle is in transit, it is going to the customer place or the dealer place, you're again capturing that data. And then it goes to the dealership, he does some tests and all that before sending it to the customer. This is where I'm saying it goes to the bodybuilder, and then in performance, when the customer is using this vehicle, every day, every 6 seconds, one data packet is being captured from the vehicle of various data parameters. It could be engine speed, oil pressure, and so on. All this put together, even during the servicing also, when the vehicle comes to the service, you're capturing data. So you seem to be capturing data throughout the entire life cycle of your product. And all this goes towards building your digital twin. Right? This is what it is. Through the entire life cycle, you capture data, and that enables you to be building this repository and that digital twin. So a digital twin, there's so much pieces, different data sets which go into building this digital twin of a truck. And I'm saying, you must have heard of this open data ecosystem, and even the government has been talking of the national open data ecosystem. You've been talking of a national open data ecosystem for the agri industry, right? Your government is now building a node. It is called a node for the healthcare sector, where the healthcare sector, all the players in the healthcare sector get together. It is the hospitals contributing data, it could be the laboratories which contribute data, it could be the wearables and the IoT devices that you wear, you capture data, and different types of data getting into a data marketplace, or you call it as a data mandi. I'm calling it as an Ayush data mandi. All the healthcare providers agree upon. It is all on a consensus basis. We all put data into one central location, right? And then that and you have a community of developers who are there to build fantastic, wonderful applications which will be useful to not only the healthcare industry but also to the community as a whole. So moving forward, I just wanted to leave you with a thought to say that you can build a digital twin of anything. The day is not far off where you will have a digital twin of every human being, Pratik, with the kind of data. Even today, if you really see, all this data is already available with us. But the problem is we don't have this in a consolidated manner where I can use a large language model and on top of that I have the generative AI and then I can drop a profile of any person. We do not have that today, but the data. But if you see the assorted data which is available, you could probably build a digital twin of every human being on this planet. So I just wanted to conclude saying digital twins are poised to reshape industries by offering a virtual window into the physical world. While there are challenges, the potential for creating new business models like what we saw, improved efficiency, cost reduction, and sustainability make digital twins a very, very transformative technology that will continue to evolve and shape our future. So what should you do as technology leaders? My last slide. The moment you get back to your office on Monday, get a team together and then start looking at what should be your vision for your digital twin project. Identify certain prototypes. Try to roll them out in the next 3 months. By December end, try to identify and then put people behind it to develop those prototypes, solutions for digital twins. Identify KPIs, see how it is received by the people. And in the next 1 year, right, once those prototypes are a success, you are poised to now take it to and then scale this further in your organization. Come out with a much larger kind of a blueprint for your digital twin. Identify KPIs, showcase the benefits to the management and to the board, and take your digital twin journey along. Thank you very much.